Deep within mineral-rich geological formations, the journey of ocean-going giants begins with the extraction of high-grade raw iron ore. Heavy machinery works around the clock, harvesting thousands of tons of raw material daily to meet rigorous industrial specifications. Geological samples are continuously evaluated on site, ensuring the mineral composition contains the exact iron density required for structural steel manufacturing. Transported by rail to the integrated steel facility, raw iron ore arrives in massive bulk shipments ready for processing. Automated conveyor networks transfer the raw minerals directly into screening systems, beginning the multi-stage refining process. Vibrating screens and magnetic separators split the material by size and purity, removing non-metallic waste to yield refined concentrate. High-pressure washing units strip away remaining surface impurities, producing pristine raw material ready for high-temperature smelting. Inside blast furnaces operating at extreme temperatures, chemical reduction converts the purified ore into liquid hot metal. Pure oxygen is injected at supersonic speeds to lower carbon content, refining the molten iron into high-tensile, structural, marine steel. The liquid steel is continuously cast into massive solid slabs, which are precise. Inside massive rolling mills, immense hydraulic pressure flattens red-hot steel slabs into heavy structural plates, tailored for shipbuilding. Controlled cooling beds ensure uniform grain structure throughout each steel plate, preventing internal stresses and material warping. Abrasive shot blasting removes every trace of oxide scale, exposing pristine silver-grade steel ready for protective priming. Automated spray systems seal the fresh metal with a temporary weldable primer, protecting plates from corrosion during shipyard fabrication. Primed plates are catalogued and transported to the shipyard stockyard, ready to be called up for computer-controlled cutting. High-definition plasma cutting gantries trace complex hull contours, slicing through inch-thick steel plates with sub-millimeter precision. Underwater plasma cutting minimizes thermal distortion along plate edges, ensuring exact fitment when hull sections are later joined. Heavy hydraulic press brakes and rolling machines curve flat steel plates to mirror the hydrodynamic lines of the vessel's hull. Technicians verify every curved plate using digital templates, confirming exact dimensional alignment before parts move to subassembly. Automated submerged arc welding bridges flat plates together into massive stiffened panels, forming the foundational walls of the ship's internal structure. Automated gantries press structural stiffeners onto flat deck panels, welding them securely to deliver maximum structural rigidity. Subassemblies are built from the inside out, interlocking flat panels with vertical bulkheads to form three-dimensional structural cells. Skilled welders seal complex internal intersections, reinforcing high-stress zones throughout the vessel's internal framework. Heavy lift cranes flip upside-down SUP blocks right side up, allowing outfitting crews easy access to internal decks. Advanced pre-outfitting installs piping, electrical conduits, and machinery foundations directly into blocks prior to grand assembly. Enclosed blast halls coat internal compartments with multi-layer marine epoxy, safeguarding ballast tanks against harsh saltwater environments. Computer-controlled modular transporters move megablocks weighing hundreds of tons across the shipyard to the main dry dock. Giant gantry cranes lower massive blocks into the dry dock berth, aligning thousands of tons of steel within millimeter tolerances. Precision laser guidance systems monitor block alignment, verifying joint gaps down to the millimeter before butt welding begins. Automated vertical seam welders ascend the outer hull, fusing individual megablocks into a single unified vessel. Inside the hull, shipwrights apply high-tonnage hydraulic tensioners to draw deck plates flush before interior structural seams are permanently welded. The main engine, the heart of the vessel, is lowered into the engine room casing before the upper deck blocks are permanently sealed overhead. Propulsion shafting is aligned to micron tolerances, ensuring smooth power transfer from the engine to the massive propeller. The main propeller is mounted and hydraulically torqued onto the shaft, engineered to deliver maximum hydrodynamic thrust across open seas. The fully outfitted deckhouse superstructure is lifted onto the aft hull, completing the primary structural outline of the vessel. External weld seams are ground flush and hand-sanded smooth to minimize drag coefficients once the hull is submerged in seawater. Specialized anti-fouling coatings are applied below the waterline, preventing marine growth and protecting the steel structure against ocean corrosion. Precision stenciling adds official draft scales, load line marks, and vessel identification graphics across the completed exterior shell. Rigorous quality inspection employs ultrasonic flaw detection to verify that every structural weld meets international maritime safety standards. Internal cargo holds and watertighter compartments undergo comprehensive physical inspections to guarantee complete structural integrity under extreme sea pressure. High-pressure water jet testing verifies that all cargo hatch seals and outer hull penetrations are 100% weather and watertight. On the bridge, technicians integrate state-of-the-art radar, satellite navigation, and automated propulsion control consoles. Thousands of sensor channels are wired into the engine control room, giving engineers real-time diagnostic control over all vital machinery. Heavy deck machinery, including hydraulic anchor windlasses and mooring winches, undergoes rigorous load testing on the bow deck. With structural assembly and primary outfitting complete, the dry dock valves open, flooding the basin with seawater for float-out. As buoyancy takes hold, the ship floats free from its keel blocks, ready to transition to the outfitting pier for sea trials. Powerful harbor tugs maneuver the unpowered vessel into deep water, positioning it for its final propulsion and sea trial phase. During sea trials, the vessel undergoes full-power speed runs, crash stops, and high-speed turning maneuvers in open ocean conditions. Every operational system meets International Maritime Registry standards, earning official classification and seaworthiness certification. Delivered on schedule, the newly built vessel takes its place at the commercial port quay, ready to commence global cargo operations. Inside the cargo holds, cell guides align standardized containers smoothly, maximizing volumetric capacity and weight distribution across the hull. Deck crews lock down outer container stacks with high tensile lashing rods, ensuring cargo remains immobile during severe ocean weather. With cargo fully secured and clearances granted, the vessel leaves port behind, embarking on its inaugural transatlantic voyage. Engineered from raw iron ore to a high-tensile steel leviathan, the vessel cuts cleanly through ocean waters with maximum hydrodynamic efficiency. What began as unrefined minerals buried deep within the earth stands transformed. A testament to heavy industry, precision engineering, and modern shipbuilding. Fluxify process, sourcing nature, shaping steel, engineering the future of global trade.